Thanks a lot, first of all, for inviting me here. And I think that this presentation is going to be somewhat complementary to what Irina was talking at one of her keynotes. So we'll go into the class of high-level Petri nets and probably slightly deeper into explaining how do you maybe model things and semantics. So you'll probably see the famous token game that people usually talk about when working with Petri nets. So when I start talking about any kind of model that I'm trying to develop, I usually start with a problem. Why do I need to have this model? And the reason why I have the model of DB nets is actually coming from this guy, the process and data dichotomy. So this is a very famous problem in the community of business process management. And essentially, this problem poses the question how to make data and processes work together. However, it might seem something rather conceptual, but when we go into the nutshell of the problem, we see that it concerns different tools that different vendors try to implement to address processes and data in some kind of synergic sense. Then these things, of course, concern formal models as soon as we try to represent these processes, and formal analysis and verification. These are things of particular interest for our group. Actually, yes, that's what we do in our group. So we work pretty much on everything, but we probably don't do implementations. We only have manpower to do prototypes. So, so how do you actually solve this problem? The answer is very simple, as usual, right? So it's somewhere in the surface. And the answer is by asking question. Are there models that correctly reflect synergy between data and processes? And the real thing is that currently existing solutions don't really do it well, because they're like the pendulum that does not stabilize. So they either try to talk more about processes or they try to talk more about data, but never find the equilibrium. And I think finding the equilibrium between addressing processes and data is the paramount of the solution of this problem. So just a quick look of actually how the data and process dichotomy work in the reality. I like when computer scientists say reality and show this kind of examples. They are very convincing. So this is a very convincing example of the booking website, right? So we all know how to use booking.com, and like what we usually do if we want to find accommodation, we go there, we put the city, we put the period of stay, and then boom, we get all the options. How do we get it? We actually type everything as the user input in the fields of the web page. We click enter, then the website talks to the booking server, then so the booking server immediately talks to the database of all the hotels that have registered on the service, and then it returns back the answer to the website. The website gives us all the possibilities. So amongst those, we choose something, and all these choices that we perform, actually some kind of intermediate user inputs, they are stored in this kind of volatile data, so say session data as I put it here. And again, talking about myself as the person who is interested about modeling, I ask again a question. Actually, how do I model all these things? How do I model case data, so the volatile data? How do I model persistent data? How do I model processes, tasks, decision logic in my whole process? And I actually want to have it all in the same pot. And that was our try back in 2017. So Marco and I, we wrote this paper that's called DB nets and the marriage of colored Petri nets and relational databases. And it's obvious, so colored Petri nets would represent the process dimension of the problem, and the relational databases would stand for the data dimension of the problem. And so DB nets, in the nutshell, they're probably having a bit of more, I don't know, more computer science oriented representation, not as mathematical as classical Petri nets do. So here we have the three-layered structure. So we have control layer, data logic layer, persistent layer to account for all these components that I mentioned before. And I'm going actually to talk about all of those three in more detail. So first of all, we start with the persistent layer. So the persistent layer is the type relational database with constraints. So we all know relational databases. We all probably understand what does type mean. We all know that databases actually have constraints like foreign keys, functional dependencies, and whatnot. And well, types is maybe something rather that we could argue about, but in our case, we just have the value domain and regionally defined predicates on it. So that's the type for us. And everything formally is represented by means of first-order logic, okay? And here is the simple example of actually two tables that we would have in the booking database. So available properties, available accommodation, and booked accommodation. That's all we need. And okay, primary key constraints. Now, how do we manipulate the data? So for that, we use this kind of bidirectional interface that allows us to interact with the database itself. So we can read from the database using queries. And probably those who are familiar with relational calculus knows that there is the correspondence between relational algebra and the first-order logic. So we can represent everything using first-order logic here. And to update databases, we use parameterized atomic actions. So parameterized, you understand, atomic stands for actions that work under transactional semantics. That means that if I perform an update on top of my database and the result of this update violates some of the constraints, then I will just end up having a rollback, like classical database rollback here. And here are two examples. One, query. So as the query, just have simple query to extract all available accommodations. And an action, parameterized action that has four formal parameters. So like book. So the action that actually allows us to book accommodation with identifier ID in CTC for period P for user U, okay? Well, there is no, right, for user U, so right, correct. And what does it do? So it removes an entry from the table with available accommodations and adds an entry into the table with booked accommodation. That's pretty much simple, right? Oh, right, and it actually will roll back if I try to book the same accommodation twice, right? So that actually can happen because I have some volatile data that may store the ID of my accommodation, and I can do this operation twice if my system is actually not modeled correctly. And the last bit is the control layer. So the control layer is a variant of colored Petri net. Why am I saying a variant? Because in let's say, more conventional colored Petri nets introduced by Jensen, you would go for finite color domains, whereas here we are working with unbounded color domains. And another non-traditional thing is that we are allowing actually our CPN to use this kind of interface. So we have actions assigned to transitions, and we also have other elements that actually work with queries. So, right, elements that work with queries in a bit. Let's talk about all the elements of our net, of the control layer. So the first elements are usually places. We have normal places that represent case data and resources. We have view places. So view places are actually actual views on top of the database. So we assign queries to these view places, and they reference via those queries the actual state of our database. So what can we do actually with these view places? We can only read data from these view places, and we cannot really explicitly modify them. So in Petri nets, what does mean explicitly modifying? That means that we take out the token, we do something with it, and we generate another token and put it back into the place. Here we cannot do it, but we can actually modify them implicitly because we have actions that can change our database somewhere, and by changing the database, maybe the view place will be also recomputed. And here is the example. So it's just representational, right? So we have view place that stands for available accommodation over there, and we have, let's say, one normal place that stands for reserved property. Okay. dynamics of our net model. So dynamics provided by the flows and transitions. So let's start with the input flow. So input flow is usually represented by place and incoming arcs into it. So the input flow, what does it do? It consumes tokens from places and it reads tokens from view places. And actually, to make the process, let's say, more sophisticated, we also have type-aware guards on top of transitions, which are essentially Boolean expressions with type predicates on them. And we have also output flow that produces tokens as customary to patronets, classical patronets. But it also provides bindings for actions, because sometimes our transitions can be labeled with actions with formal parameters, so we need to give some bindings to those parameters. And we also have the kind of special variables which are called new variables, which allow us to generate globally fresh data. This is needed, for example, when we want to talk about unique identifiers in our model. Like you've seen on the example before, there were session IDs. So every session that I start on the booking website should be a unique one. Okay, let's start modeling. So we are starting with this two simple elements. So we have our view place, because we remember that we need to access our database. And when we start booking, we need to insert user data. So we actually generate with this new place, right? Here, we generate the fresh session identifier. And then with these two variables here, C and P, we somehow model the user input. So user with C inputs the city, with P inputs the period of stay, right? Okay, so as soon as we have done that thing, we can actually reserve the accommodation. How do we reserve accommodation? Well, we basically talk to our database. So we have now in our token some data about desired place and period. We know that there is a list of available accommodation. What basically we need to do this some sort of join, right? So we join, and if actually this join succeeds, then our net can go on. And can go on by extracting the identifier of accommodation available for that precise period. Well, and then we enter user details, and if everything is fine, so we finish booking. Okay, so now I show you the token game. So token game, when you press transitions and move tokens in the net. So we start with that kind of setting where we have two available properties, one in Tbilisi, another one in Munich. And we say, okay, fine. So now I would like to book something in Tbilisi for the kind of period from November 7th until November 9th. Okay, fine. I'm booking it. So I have my token here now in the place. Now I'm going actually to check with reserve whether I'm not showing here the assignment of variables, but I think it's kind of understandable what's going on here. I'm now going to check whether actually I have Tbilisi in available accommodation, and indeed I do. So I say, okay, fine. I pick it up. I now remember in my volatile data, I remember the ID of accommodation that I have selected, and I go on. So I now need to enter user details, and I say, okay, let's say user details, just the name of the person, it's going to be N. And N is just reserved the property. Now what she needs to do, she needs probably to go finish booking, but she's currently looking for her credit card. So she takes time. At the same time, what happens, another guy comes and starts looking for the same period in Tbilisi, right? So probably they're all coming from TMPA. So another guy comes, sees it's actually still available, right? We again have another person looking for Tbilisi, ready to put user details, but the person doesn't because Anna found her credit card. She enters needed data, finishes booking. What does happen when the booking is finished? So the property is not available anymore. And the property is now booked for N, but there is a guy in the system hanging. The guy goes on, so this is Mike. Mike goes on, says, okay, actually looks like reserved. What can I do now? I finish booking. there a problem? Yes. We have constraint violation. Yeah, perhaps they're married, but we don't know it, right? Well, that's the problem. We roll back. And actually, when we roll back, so we lose some portion of information about what had happened in the system. So we'd like to have the rollback more meaningful. So we're adding another element to our net, which is called the rollback flow. So this is the flow that allows us to, so this is the flow that we can follow, we can follow when update has failed, right? The update on the database. And actually, rollback flow can model kind of undo or compensation in our net. And that's actually what happens here. So again, let's look into the thing. I added now the compensation flow here. So I'm going to tell Mike that now Mike should choose another property. And that is what's going to happen. So now Mike tries to book. Failed, of course. But now I move Mike on another flow of my net that actually will redirect him on the initial step where Mike will need to look for other available properties and so on and so forth. So this is pretty much how DB nets work. Now the question is actually what can we do with DB nets? And here I have, actually in 2 years we managed to do quite some things. I'm actually surprised about it. Usually it takes much longer for a new formalism that pops out of nowhere. So that was quite a successful thing, and it still goes on. It's application to formalization of enterprise application integrations. It's joint work with Daniel and from SAP and Stephanie from University of Vienna. So what we did there, essentially, we did modeling of integration patterns and their composition. So these are things that you use in kind of big enterprise projects. And we used prototype that master student of ours implemented during for his thesis, which is based on CPN tools and Access CPN. And what we also did for this kind of models, we did correctness checking via simulation. And currently, we go on with this project, and we're trying to apply to multimedia databases, to multimedia scenarios for enterprise integration patterns. What we actually like to do in the future, but that's only for modeling and simulation, basically. So in the future, we would actually like to develop a new prototype. And I already know that there were a couple of ideas coming from the side of Higher School of Economics, basically from the group of Irina. So they're now picking up another tool, and they would like to develop something that actually will most likely subsume even DB nets. So let's hope that the development goes on well. And another thing that we would like to do is data benchmarking, which is a nice thing also for people who do process mining, because using an actual process that is connected to the database, you can model very complex scenarios, generate any kind of data, and then on top of these data, you perform any kind of process mining techniques. Then another thing is about extending the framework. So we were before thinking actually on adding more databases, because here you're seeing that we have only one persistent storage, so it would be nice to work with distributed setting of DB nets. Then in the work with Daniel, we used also an extension of DB nets with time, which was not formally defined. So this is yet another thing to work on, and making extensions of Petrinets with time is a really painful job, so I think it will be an interesting effort. Again, I probably should mention that there was also a proposal from Ina's side coming about working on a, let's say, bigger, more generic model, for which actually which should be supported by the tool. So let's see how it goes. Then thing that we are also interested in a lot is verification. So for DB nets, we have some results. Let's say some conjectures regarding verification, that it is decidable for bounded DB-nets, and the verification type is for properties defined in the first order variant of mu calculus. So it's very, very expressive logic, which you probably would not use in practice, but it's a nice result that sets up the baseline, so you can go on for, let's say, more for easier logics like CTL, for example, and work on techniques there. Then there is also reduction that we worked on with Markov from a class of DB-nets to a class of CPNs, and there it's also nice, let's say, for verification, because you can just use normal CPNs using CPN tools. Then you, in CPN tools, implement an approach that allows you to generate finite state abstraction of your net, because apparently these nets are Turing powerful. The transition systems they generate are infinite state, and not only because of loops that you might have, but also because of the data that you have in it. And another thing that we're currently working on is verification of DB-nets using satisfiability modular theories. So we are in particular looking into the theory of arrays, and we also have some results for, let's say, more business process oriented side, and we want to apply it now to DB-nets. That's it. Thank you for your attention.